Yes, thank you very much. I hope you can hear me. Bauma has put this show under the motto, break the speed limit. We see improving the speed addresses various aspects that we see at the applications our customers want to solve. And with this presentation, we want to show you how you can use GigE Vision for ultra high-speed applications. My name is Mirko Benz. I'm working as Head of Product Manager at the Vision Competence Center at Bauma. So this already works. Yeah, just a few words about Bauma. We are international, family-owned business. Since more than 70 years, we are leader in sensors that are used for various factory automation applications, like encoders, position sensors, and so on. If you have any task within the factory automation industry and you're looking for a sensor, there's a really good chance that Bauma has the right product for you. In terms of vision, we produce machine vision cameras and smart vision products also for more than 25 years already in Germany. And also here we cover a broad range of cameras. We are active worldwide, roughly 2,800 employees, something like 500 million euros in turnover every year. So we are one of the bigger companies providing machine vision technology. The topic for today is really how can we address really the most advanced application with standard GigE Vision technology. Of course, we have a broad range of mainstream cameras with GigE and USB interfaces, which address almost any application that you will find in the machine vision industry for quality inspection. However, what we see is more and more customers would like to improve the accuracy, the quality of their inspection, but also they would like to improve the throughput of their inspection systems. And both higher resolution, higher throughput requires more and more bandwidth. For example, if you take a high-speed or higher-speed camera with 24 megapixels at 50 frames per second, then you already need a 10 GigE interface, something that is no longer mainstream. Such applications are typically found in electronics, but also semiconductor industry. It gets more and more complicated if we increase the number of cameras that are used in a system from one to many. We have several applications where we use 20 or even 30 or more cameras in a single system at a single PC. And of course, if you have such 10 GigE camera systems with such a high camera count, then the total bandwidth is really huge, and that's something that is really looking for a new approach. What is in use today and was introduced already 20 years ago was GigE Vision. At that time, 2006, when the standard was rolled out, GigE was considered a very fast interface compared to the other interfaces of that time, like USB 2 or FireWire, and therefore the overhead of the protocol processing that was pushed on the operating system and the CPU was considered doable. The general approach here for standard GigE Vision is to use a dumb network interface card which receives the images that are packetized by the camera and just forwards these packets to the operating system. However, this involves a lot of overhead, like copy operation, like context switches, handling interrupts, and so on, which really limits the ability to really achieve very high speed. And therefore, we need a new approach to really tackle these more demanding applications. From our aspect, the real or right approach is to continue with GigE Vision, but exchange the streaming protocol towards using RDMA. RDMA basically means that the camera is now able to directly put the images into the buffer of the application. It requires a smart NIC, an RDMA-capable NIC, or network interface card that can do a lot of the protocol processing already in hardware. It's message-based, it allows to do error detection, but also helps to do error recovery by doing retransmission. And as a consequence, the operating system is now no longer in the data path. This really frees up a lot of CPU and paves the way to really high-speed applications. We did, for example, tests with 100G network cards. We get close to the line rate, 99 gigabits per second, at just 3% CPU utilization. So this is really a remarkable performance that can be achieved with this new technology, and we want to make it possible to use this also now for standard GigE Vision cameras. For high performance applications, the dominant camera series we have is our LXT with a 10 GigE interface. With this camera we have integrated various modern CMOS sensors from Sony, like generation 2, 3 and 4, up to 24 megapixel, but also modern CMOS sensors from GPixel up to 65 megapixel. With this camera line we can fully utilize 10 GigE line rate, but also have other unique features like image pre-processing, like shading correction, but also quite advanced color calculation, for example. We also have very strong connectivity, like lens control for liquid lens connectivity, for example, but also a really good robustness with this camera, supporting IP67, but also M12 connectors for harsh environments. This camera line was already introduced 2018, and now we are coming up with a free of charge firmware update, removing the standard way of GigE Vision and replacing it by streaming via RDMA. The key advantage here that customers can have is a significant reduction in terms of CPU utilization. Then a 10 GigE camera just needs 1% of CPU to use the full bandwidth of 10 GigE. We keep the reliability of GigE Vision, so we not just do error detection, but also error recovery. This is a major aspect. So to keep the reliability, our SDK supports both Windows and Linux, the major operating systems that our customers use. We made the migration to RDMA really smooth. Customers can do this within 1 day, so it's really straightforward to migrate to RDMA and reap the benefits of it. Of course, we also plan to roll out this new approach of RDMA to our other cameras of this 10 GigE family. What's the new highlight at this Vision Show is probably the most advanced camera that you will find here at this Vision Show. It's our new QXF high-performance multi-head board-level camera. This is primarily designed for very demanding OEM customers that really need the highest performance that is possible in the market. Being a board level and having this remote heads, it also allows a very deep integration into the devices of our OEM customers and giving a lot of flexibility, for example, where to put the sensor heads in the system design of our customers. The first product we release is our 24 megapixel dual head camera. Both sensors run at full speed of 100 frames per second. Another highlight here is that we also have further GigE and NBST ports. They can be used, for example, to communicate with the system controller of a complex device, but also attach a monitoring camera if you want to see also a different aspect of your scene. All these data streams are combined within a single switch that is integrated into the FPGA, so that we need just one single link here of 100G using a QSFP port to the PC, so just one single cable can combine all these data streams. As I said, this platform is very powerful. We are able to do this based on projects. We can attach up to 6 Sony Gen 4 sensors at full speed, so really a lot of performance can be achieved. So where customers want to really look at very big objects or from different angles, that's a great platform to do this. We also have very extensive FPGA resources to additional image pre-processing, like 3D processing, or also compression if needed. We can also adjust various aspects of these platforms, but tailored always for specific OEM applications which have really advanced demands, but also the volume to make such customization worthwhile. Of course, also this camera supports RDMA, and this slide basically summarizes, in our opinion, what are the key benefits our customers will get by using RDMA. Of course, it's very high performance. We just not have to keep at 10 GigE. We can now go to 100G and beyond. It's reliable. It does not just do error detection, but also retransmission in hardware. That's a real difference. We can do retransmission with real-time, very low latency. It's very efficient. We have just a few percent CPU utilization at very high bandwidth. So the majority of the CPU is now available for the image processing application. It's cost effective. It's using standard network cards. That's a real differentiation when we compare this to other approaches that are used today for high-speed imaging. These network cards are designed for other industries with really much higher volume and also available from various vendors that are providing network interface cards, for example. RDMA is a technology that is just new to vision. It's not new to other industries. It was designed at least 30 years ago for high-performance computing, and has proven its value for other very demanding industries like storage, but also financial industry and so on. And we are now also taking advantage of this very advanced technology for our cameras. It keeps the scalability advantage of GigE Vision, so we can rely on switches, build really huge camera networks. We have projects where up to 100 cameras are attached to a single PC. So that's really a remarkable feature, something that's not really doable with a frame grabber-based approach. It keeps the ease of use of GigE Vision in various aspects. A customer can get full support for entire system, software, camera, network interface card from a single supplier. It's also the case that various third-party software vendors will directly support RDMA. And last but not least, it's future-proof. So from my perspective, that's a really useful interface for at least the next decade, where we can rely on and have much higher performance than we are able to use today. In terms of system setups, we really see that we can use the same setups that our customers are used with the GigE Vision and 10 GigE cameras that we have today. So we can use direct connections based on available 10G dual-port camera, dual-port network interface cards. We can use the same approach for dual-port 100G network cards, but we can also use switch-based setups. For example, we have setups where we connect 20 10G cameras via RJ45 copper cables, and then use just 2 uplinks of 100G to the PC, so drastically reducing the amount of cables and interface cards that are needed in a PC. We can also use high-performance embedded NVIDIA systems based on this PCI network interface cards, and even laptops are supported by Thunderbolt adapters. So basically all the use cases that our customers love about GigE Vision are still possible now with RDMA. Of course, we really do a lot of testing with this technology, and we have a test bed with 16 cameras, 10G at full speed, running at an aggregated bandwidth of 160 gigabit. So that's really a lot of bandwidth when we compare this to a single GigE camera. So 160 times GigE cameras. We can achieve full bandwidth at just a mere 4% CPU utilization. So this is really a breakthrough with what we can achieve with RDMA, and which would not be possible with standard GigE Vision that our customers used before. What's also really important, we did this test over a long time, more than a couple of days, without losing any image, without losing or without any corrupt image. Of course, when doing this acquisition over a long period, there are some errors that occur during the transmission from the camera to the PC. With this approach, we can correct these errors in real time because we have retransmission capabilities. And as you see, the CPU is now no longer involved in the data processing and therefore is free for the actual application processing. However, of course, customers that really would like to see such very demanding systems now need to look into memory bandwidth, but also selecting the right PCI slot, having the right bandwidth, for example, for these high-performance network cards. GigE Vision 3.0 will support RDMA. It's now available also already as a white paper. You can see more data at the A3 web page. From our perspective, the proposal that is there for GigE Vision 3 over RDMA is already good enough for developing cameras, but also third-party software. We are releasing our cameras and our software. Customers can buy these pre-release products already, and we also see fast adoption by third-party software manufacturers. So this will really also drive the ecosystem of GigE Vision over RDMA. We expect full approval of this standard next year, and also then we will have fully compliant products. Bauma will host this year International Vision Standards meeting at our new innovation center in Switzerland next week. And the main idea here is to further work on the standardization, and we hope with the engineers that will gather there, we will also improve the finalization of the standardization. As you can see here, A3 is hosted by the the GigE Vision standard is hosted by the A3 standard, and they also see GigE Vision over RDMA as a leap forward for GigE Vision, but also for our entire industry. So, what does GigE Vision basically bring you? It's the three aspects that customers that want to design high-speed systems are really looking for. High performance, reliable systems, but also low CPU utilization. But that's also something you can get today with other frame grabber-based approaches. With RDMA, using GigE Vision, you can get much more than what's available today with a frame grabber-based approach. Since it's using off-the-shelf network interface cards that were designed for much bigger industries in much higher volume, they're very price attractive. You can buy, for example, these 50G network cards having more bandwidth than a typical high-end frame grabber today at a much smaller form factor with much less power consumption. Since it's designed really for bigger industries than we are as Vision, but we can take advantage of it. If you look at the lower picture, it shows a 400G network interface card. You can buy it today. It has 10 times the bandwidth of a frame grabber that you can buy today, and it's available now. And from our perspective, this advantage in terms of technology will always be there and will continue to be improved. GigE Vision is now already, Ethernet is now already at 800 gigabit, and more is developed. So this is really something we can rely on for the future. The main difference that we see when we look at CoreXpress, for example, is the ability to have really 100% original images. With CoreXpress, the frame grabber just does error detection, but not error recovery. That's a key aspect and the main advantage we see here. If customers want to have really 100% of the original image, there is no way around retransmission, because errors over the communication will happen over time. It's just a question of when. We can keep the advantage of building really large systems. It's network-based, whereas frame grabbers are just point-to-point. So using network switches, we can build really large systems, 100 cameras connected to a single PC. That's really doable with this approach. We can also have more advanced mechanisms like failover or load balancing, taking advantage of RDMA. So a single receiving PC can easily forward a part of the image via RDMA to another PC to do additional processing, for example, of the image, or to do some monitoring. So that's really also straightforward when doing RDMA. And as I mentioned, that's also a key differentiation. GigE Vision is one of the key standards. It has always been supported directly by the major third-party software vendors. Customers can go to the third-party software vendor and get direct support. This is not the case for a typical frame grabber, where you have to go to 2 different parties when you are looking for support if something does not work. And we Bauma have decided a couple of years ago to stop this developments for frame grabbers, since we have seen more potential in this standard interfaces. To summarize, GigE Vision is clearly the dominating interface that our industry is using today. More than 50 cameras 50% of the cameras that are sold worldwide are using GigE Vision today. With 10 GigE, we could already drastically improve the performance of these cameras to a new level while keeping the underlying protocol. This is still a very good approach for small systems with 10 GigE. However, if we are really looking for really big systems or want to maximize available CPU or CPU resources for application processing, then RDMA will bring GigE Vision to a fully new level. And it really keeps the price performance advantage of standard network interface cards. And really, from our perspective, there's no longer need to use frame grabbers anymore. Yeah, just last slide. Thanks. I would like to invite you all to visit our booth just over there in the center of this hall. In addition to our new RDMA cameras, we will also show you some non-visible, inspect the visible cameras with sphere and UV, but also a really interesting camera, all-in-one integrated, very compact form factor for entry-level applications. Also a device that is pretty unique in the market. Thank you very much.